This example is referring to the curve fitting problem. So we do have a set of points on a plane, and we want to find out a second degree expression that approximates the behavior of these points in the best way. So it means that that line should be somehow representing these points. Okay, so the input parameters are the locations of these points. Let's call them xi and yi. And the question is, what are the coefficients of this expression? A, B, C are the decision variables. Okay, so let's have a look at the Python code. Okay, so this is example 26. Okay, so first of all, I import all the required packages. This is an abstract model. So n can be a number of solutions. That's the number of points that I want to draw a line between them. I is the set that represent each node, and also A, B, C are the variables, and we have a model .of, which is going to be representing the objective function, which is the error of estimation. Okay, so first of all, I create some random points on the plane, and then write down the objective function, which is model A multiplied by x location square plus b dot model x location plus c minus y location. Okay, and a square. It means that I'm trying to find A, B, C in a way that the difference between the line and those points are minimum. The square of that is minimum. And since it's a non-linear programming, I have to use IP opt, and then I'm using the model.n, yeah, for this purpose, and run it. Okay, and the points are here, and the line is through all of them. Okay, and that's it. Thank you.